Fomalhaut aliens from the star of dreams Eye of Sauron. Location, home system, the brightest star in the constellation of Piscis Austrinus, the southern fish. Piscis Austrinus is found between the constellations of Aquarius and Grus. Distance from Earth, about 25 light-years from Earth. Average height, feet, 6 inches to just over 6 feet. Hair, blonde, dark hair and brown. Eyes, very blue, hazel, black or steel gray eyes. Other physical information. The first variety of Fomalhaut humans closely resembles the so-called Nordics type of ETs, and are usually blonde with very blue, hazel or steel gray eyes. Men are muscular, and around 6 feet, 1.85 meters, tall. Women are very buxom and range from 5 feet, 6 inches to just under 6 feet, 1.68 to 1.83 meters, in height. The second type is darker skinned and looks almost tanned, with dark hair and brown, gray or black eyes. Same relative height and appearance as the first so-called Nordic type. The Confederation's dinoid reptoid inhabitants are a hybrid originally from the star Bellatrix in Orion. Very scaly and bony. Upper head is surrounded by large bony crest. Large red or dull yellow eyes, resembling those of Earth's reptiles, are large and set forward just above, and to either side of, very small nose. Mouth has thin lips that run from one side of head to the other. Ears are non-existent, only sign of them is an extra smooth 3-inch, 7.62 centimeters, circle on either side of head and just behind eyes. Skin is scaly like crocodiles and green, yellow, brown or red in color. Small crest of bony material runs up middle of back and is connected to larger crest found on the top of head. Beam is bipedal. Thin hand has 6 long, clawed fingers. Feet have 5 toes ending in small, very sharp claws. Very small tail, thick like crocodiles, extends only to feet. Male is shorter than female. Bellatrician-like males on Fomalhaut range from 8 to 10 feet, 2.44 to 3 meters, in height. Females are 8.5 to 10.25 feet, 2.6 to 3.12 meters, tall. Special traits and abilities, noted for prowess in all scientific endeavors. They now comprise a large part of the personnel of first major science and exploration team sent to Andromeda, some 2 million light-years from our galaxy. Communication type, human language is lyrical but guttural, dinoid reptoid language is much more guttural. Life form type, 2 members. First, a human rebel group from the Pleiades that first colonized Fomalhaut some 250,000 years ago, and who are now found on Fomalhaut's 3rd and 4th planets.
Second, a smaller dinoid reptoid group from Bellatrix in Orion, that colonized the 2nd planet in this solar system some 200,000 years ago. The two parties created this confederation after a series of very destructive wars that ended some 20,000 years ago. Transportation type, human scout ships are ovoid, like water drop about to fall from tap. They range from 60 to 85 feet, 18.3 to 26 meters, in diameter. Mother ships look like huge multi-layered cigars and are from 2 miles to 1,200 miles, 3.2 to 1,920 kilometers, across. Dinoid reptoid scout ships are shaped like huge beetles, approximately 100 feet, 30.5 meters, in diameter. Mother ships are shaped like amoeba and are some 8 to 900 miles, 13 to 14,400 kilometers, across.
Humans have catalogued the star Fomalhaut for at least 2,000 years without knowing it as anything more than the 18th brightest stellar object in the night sky. But in the 21st century Fomalhaut has become a key system in the quest to understand the nature of planets and their formation. This relatively massive star, about 90% more massive than the Sun, is very young, clocking in at somewhere between 100 and 440 million years old. It's also surrounded by a set of so-called debris disks, material that represents both the detritus and building blocks of planetary objects. In 2008, Hubble Space Telescope images yielded a tentative detection of visible light scattering off dust around a massive planet orbiting Fomalhaut approximately every 1,700 years. Subsequent data has confirmed this detection by seeing the planet move along its orbit, and suggests that it could be a few times the mass of Jupiter and is surrounded by its own circumplanetary cloud of interplanetary muck. This world also orbits just inside the realm of a vast ring of dusty material, encircling the star at an average distance of about 20 billion kilometers. Now Matra et al. Have announced that this outer ring is aglow with millimeter wavelength radiation. The luminous tracer of carbon monoxide gas, itself a prime signpost for rich icy material circling the star. The bottom line is that this 100 billion kilometer circumference ring, with a width of approximately 2 billion kilometers, is likely revealing the presence of a vast population of icy excrements. As these objects collide with each other, either in a few massive collisions, or a stream of cascading pile-ups, some of their frozen gases are released to interplanetary space. The researchers suggest that the mix of carbon monoxide and carbon dioxide in the Fomalhaut system is similar to that seen in cometary bodies in our own solar system. In other words, by studying Fomalhaut we might gain insights to what happened in our own deep past. In fact, this glowing ring could be telling us that the system is experiencing a version of the late heavy bombardment that is often proposed for our own solar system about 4.1 billion years ago. In this scenario, the early rearrangement of giant planet orbits can disturb the orbits of smaller bodies throughout the system, causing a steady and brutal pounding of the inner planets by asteroids and cometary bodies. At a distance of 25 light-years, and with an expected hydrogen-fusing lifespan of a mere billion years, Fomalhaut is a pretty alien system, yet it may be experiencing the same planetary phenomena that helped make our own family of worlds.
Astronomers using the Atacama Large Millimeter, Submillimeter Ray, ALMA, in Chile discovered that planets orbiting the star Fomalhaut must be much smaller than originally thought. The discovery was made possible by exceptionally sharp ALMA images of a disk, or ring, of dust orbiting Fomalhaut, which lies about 25 light-years from Earth. It helps resolve a controversy among earlier observers of the system. The ALMA images showed that both the inner and outer edges of the thin, dusty disk have very sharp edges. That fact, combined with computer simulations, led the scientists to conclude that the dust particles in the disk are kept within the disk by the gravitational effect of two planets, one closer to the star than the disk and one more distant. Their calculations also indicated the probable size of the planets, larger than Mars but no larger than a few times the size of the Earth. This is much smaller than astronomers had previously thought. In 2008, a NASA ESA Hubble Space Telescope image had revealed the inner planet, then thought to be larger than Saturn, the second largest planet on our solar system. However, later observations with infrared telescopes failed to detect the planet. Combining ALMA observations of the ring's shape with computer models, we can place very tight limits on the mass and orbit of any planet near the ring, said Aaron Bowley, a Sagan Fellow at the University of Florida, USA, who was leader of the study. The masses of these planets must be small, otherwise the planets would destroy the ring, he added. The small sizes of the planets explain why the earlier infrared observations failed to detect them, the scientists said.
The original ALMA research shows that the ring's width is about 16 times the distance from the Sun to the Earth, and is only 1/7 as thick as it is wide. The ring is even more narrow and thinner than previously thought, said Matthew Payne, also of the University of Florida. The ring is about 140 times the Sun-Earth distance from the star. In our own solar system, Pluto is about 40 times more distant from the Sun than the Earth. Because of the small size of the planets near this ring and their large distance from their host star, they are among the coldest planets yet found orbiting a normal star, added Aaron Bowley. In November 2008, Hubble astronomers announced the exoplanet, named Fomalhaut b, as the first one ever directly imaged in visible light around another star. The object was imaged just inside a vast ring of debris surrounding but offset from the host star. The planet's location and mass, no more than 3 times Jupiter's, seem just right for its gravity to explain the ring's appearance. Recent studies have claimed that this planetary interpretation is incorrect. Based on the object's apparent motion and the lack of an infrared detection by NASA's Spitzer Space Telescope, they argue that the object is a short-lived dust cloud unrelated to any planet. A new analysis, however, brings the planet conclusion back to life. Although our results seriously challenge the original discovery paper, they do so in a way that actually makes the object's interpretation much cleaner and leaves intact the core conclusion. That Fomalhaut B is indeed a massive planet, said Thane Curry, an astronomer formerly at NASA's Goddard Space Flight Center in Greenbelt, MD. And now at the University of Toronto. The Discovery study reported that Fomalhaut B's brightness varied by about a factor of 2 and cited this as evidence that the planet was accreting gas. Follow-up studies then interpreted this variability as evidence that the object actually was a transient dust cloud instead. In the new study, Curry and his team reanalyzed Hubble observations of the star from 2004 and 2006. They easily recovered the planet in observations taken at visible wavelengths near 600 and 800 nanometers. And made a new detection in violet light near 400 nanometers. In contrast to the earlier research, the team found that the planet remained at constant brightness. The team attempted to detect Fomalhaut B in the infrared using the Subaru telescope in Hawaii, but was unable to do so. The non-detections with Subaru and Spitzer imply that Fomalhaut B must have less than twice the mass of Jupiter. Another contentious issue has been the object's orbit. If Fomalhaut B is responsible for the ring's offset and sharp interior edge, then it must follow an orbit aligned with the ring and must now be moving at its slowest speed. The speed implied by the original study appeared to be too fast. Additionally, some researchers argued that Fomalhaut B follows a tilted orbit that passes through the ring plane. Using the Hubble data, Curry's team established that Fomalhaut B is moving with a speed and direction consistent with the original idea that the planet's gravity is modifying the ring. What we've seen from our analysis is that the object's minimum distance from the disk has hardly changed at all in 2 years. Which is a good sign that it's in the nice ring sculpting orbit, explained Timothy Rodgers, a graduate student in the University of Arizona and a member of the team. Curry's team also addressed studies that interpret Fomalhaut B as a compact dust cloud not gravitationally bound to a planet.
Near Fomalhaut's ring, orbital dynamics would spread out or completely dissipate such a cloud in as little as 60,000 years. The dust grains experience additional forces, which operate on much faster timescales, as they interact with the star's light. Given what we know about the behavior of dust and the environment where the planet is located, we think that we're seeing a planetary object that is completely embedded in dust rather than a free-floating dust cloud. An astronomer at the Space Telescope Science Institute in Baltimore, MD. Because astronomers detect Fomalhaut B by the light of surrounding dust and not by light or heat emitted by its atmosphere, it no longer ranks as a directly imaged exoplanet. But because it's the right mass and in the right place to sculpt the ring, Curry's team thinks it should be considered a planet identified from direct imaging. There are potentially thousands of exoplanets, or planets outside our solar system. The last of these scary, spooky exoplanets listed was Fomalhaut B, within the Fomalhaut star system. The planet resides in dust debris 25 light-years from Earth, making images of it look like the eye of Sauron from Lord of the Rings. While none of these exoplanets would be pleasant to Earthling senses, the way aliens react to them is a different story. It's not clear what kind of life exists on these planets, if any, but if they're out there, they're probably much tougher than we are.
So I hope you like this video. Please share our videos on Facebook with your friends. Don't forget to do like, subscribe and comments on our video. Thanks for watching.